All right, so today we're going to learn about arcsine, arccosine, and possibly even arctangent here. Basically, when you hear that term arc, it's another way of saying inverse sine or inverse cosine. If you think about back to the days of the calculator, you might see this written as sin and then have that raised to the -1, and it's the inverse of sine or the inverse of cosine or the inverse of tangent. Each of these basically are indicating I'm giving you the answer and I want you to go back and find out when this happens. In other words, I'm giving you what the ratio of sides are. I want to know what angle will make that true. And so in this first question that you see in front of you, cosine x equals 1/2, I basically am asking, when does cosine equal 1/2? Now, this question is not limited to just the first quadrant. We want to expand it to whatever domain they're asking. Typically, it's 0 to 2 pi. And if I don't ask, it's understood, or the clep doesn't ask, it is understood to be 0 to 2 pi, unless they otherwise specify. So we're going to look at both types of domains, 0 to 2 pi and then -2 pi to 2 pi, and hopefully we'll address both of those issues. So to start with, let's ask this question. And now it helps if we remember what that chart is, and I would encourage you to write that chart down on your own. But for the sake of time, I'm just going to have us look at my chart that I'm going to pull right out here. And so looking at the chart, when does cosine equal 1/2? Hopefully you can see it right there. Cosine equals 1/2 at pi over 3. So to answer this question, right off the bat, we understand that it's pi over 3. Now the piece that we need to pay attention to is this is saying positive 1/2. Even though it's not written, we understand that to be positive 1/2. So we have to consider, when is cosine positive? And so we know the little trick. All students take calculus. And we remember that it's in the first and in the fourth quadrant. So the first quadrant angle that we want is pi over 3. Now, what is the second quadrant pi over 3 angle? Wonderful. And how about the third quadrant angle? Did you remember this time that the 3 and the 3 canceled out, so we could skip right to the 4 pi over 3? And then the fourth quadrant angle is, I meant to write that in a different color, sorry about that. So it's 5 pi over 3. Now, knowing that, and you'll notice I wrote it in a different color for the very purpose that we understand that cosine is positive in the first and the fourth. So the only ones that I would want are the first and the fourth quadrant. The other two are negative. And so I don't really want those. Now, what if I expanded the domain to include -2 pi? Well, the pi over 3 and the 5 pi over 3 would still stick because that's the 0 to 2 pi part. Right? But what I want is now the -2 pi, or the 0 to -2 pi. If you think about when you go backwards, and I'll even write these all out, you have -pi over 3. And what quadrant would that be in? Good, the fourth, and we want to keep that one. Then there would be -2 pi over 3 and -4 pi over 3, because that right there would be the third and the second quadrant. We don't want those two. And then I would be left with the -pi over 3. Sorry, it's kind of smushing together here. So what I want is -pi over 3, or sorry, -5 pi over 3, -pi over 3, pi over 3, and 5 pi over 3. Interesting. All right, let's look at another one. Cosine x equals -1 over root 2. In the same way that we just addressed the last one, we basically are asking yourself, when does cosine equal that? And so when is the first time? I hope many of you are saying, well, I know that it's a pi over 4 angle, but we have to consider the fact that it is, in fact, negative. So we really don't want the first quadrant angle. I want the, which ones? The second and the third. So I want 3 pi over 4, and I want 5 pi over 4. And although 7 pi over 4 is a pi over 4 angle, it wouldn't be where cosine is negative, so we're just going to cross that one out. So that would be my answer for the domain range of 0 to 2 pi. Now, if I expanded that to be -2 pi to 2 pi, on the opposite side of things, we would have the 3 pi over 4. But -pi over 4 would be the 4 fourth quadrant, we don't want that. Negative 3 pi over 4 we would want, because that's in the third quadrant, negative 5 pi over 4. Have you noticed any pattern about that? Now be careful overgeneralizing, because that is not always the case, that it's just a matter of switching the sign. So be very careful in just generalizing that, because you want to look at sine and tangent to see if that's also true. Okay, so now let's do this tangent question. Tangent of x equals 1 over root 3. So when does tangent equal 1 over root 3? Pi over 6. Good. The next question, of course, that we want to ask ourselves is, what quadrants is that true? When is tangent positive? So when we again look at that, we want the first and we want the third. So we want pi over 6. 5 pi over 6, do I want that one? How about 7 pi over 6? Do we want that one? What about 11 pi over 6? Which ones do I want? I want the first and the third. And so those would be the answers. Now if we did the negative 2 pi to 2 pi in a similar way as we did the ones before, I'm going to just kind of move my screen a little bit. So again, we would have pi over 6, and we would have 7 pi over 6 from the ones that we just figured out. But on the other side, what other ones would we want? Negative pi over 6, would it be negative 5 pi over 6, negative 7 pi over 6, or negative 11 pi over 6? Which ones would we want? We want the first and we want the third. So the first was negative 11 pi and negative 5. So you'll notice it is not just the opposite. Be very careful generalizing that like you might have with this cosine. It is also true for sine, that sine and tangent both. It is not just the switch of the signs. So take advantage, I guess, of the cosine, but not so much with the tangent and the sine. So, all right, so that's how we do the inverse, or the arc sine, arc cosine, and arc tangent.